Hello everybody, I'm here to solve problem 1.2 in the book Data Design Fifth Edition by Mano. And the question asks, what is the exact number of bytes in a system that contains A, 32K bytes, B, 64M bytes, and C, 6.4G bytes? And so before we begin, the reason why we want to do a problem like this is that digital design is all about computers, and computers have things called hard drives or memory and things like that that can store a certain amount of data. And so when we think of like when you think of smaller systems, it might be a very small amount of data, like a couple of bits. But when you get to very, very large computers, they can have million, billions and trillions of bits. And so we kind of like to put bits into something called a byte. A byte is 8 bits. And so I can show that here example. So there is there is like it says here, yeah, a byte is equal to 8 bits and can accommodate one keyboard character. And so that's usually the idea of how we kind of think of storing data, and that you kind of want to keep it in bytes. And that when you get larger and larger data sets, we can have millions, billions, and trillions of bytes. And this question is going to kind of ask, like, oh, okay, how can we quickly calculate how many bytes are in a certain amount of number? Basically, how many bytes are going to be given the unit and the number we're given. And so that's what we're going to do in this question. And this question is quite simple. So let's first start to number A. So to find the amount of bytes, all we have to do is just basically multiply the number up front by the unit we're doing the conversion to. So 1 kilobyte is around 2 to the 10 bytes. One megabyte is 2 to the 20 bytes, and 1 gigabyte is 2 to the 30 bytes. And so we just multiply this conversion factor, and we'll get our solution. So this would be 32 times 2 to the 10 equals. And I'm going to calculate it here because I want to kind of see around the exact value you get. So let me see if I can get this to focus. Okay. Not sure y'all can see that too well. Oh well. I'm gonna just put it in the calculator and you're gonna see my answer at the end. So it'll be 32 times 2 to the 10. And that would be around 32,000. This would be 32,768 bytes as our first answer. And then for B, we just repeat the same process. So it would be 64 times 2 to the 20. If we do that, so 64 times 2 to the 20, we get this quite large number. So we get 67,108,864 bytes. And for C, we would just do the same thing. It would be 6.4 times 2 to the 30. And I'm assuming for this answer, I'm gonna get scientific notation. Probably answer. Yeah. So we can round this to be around like 6.87 times 10 to the 9. And we do that, it would be 7 zeros up front. So this would be equal to 687,000,000,000. And if we add the commas, you get 6.8 billion bytes. And we can see that when you're dealing with computer storage and memory, we have a lot of storage, a lot. And so we always use these certain units, so we can kind of conceptualize like, oh, instead of saying, oh, we got 6.8 billion bytes, we could say like 6.4 gigabytes. So that's a solution.